As a Java developer, we work with data all the time, and 99% of the applications that we would develop would interface with some sort of a database. Mostly it's relational, but generally, as an application, it would need to talk to a database in order to get the data, and the data is the so-called life of the application. The typical way to connect a Java application to a database would be through JDBC. JDBC is some set of APIs which allow us to connect to any database provided we have the drivers and execute SQL queries and run insert statements, updates, deletes, and even fetches. JDBC has been used for many years now, and it's a good enough set of APIs. It serves the purpose. Any interaction that you want to do with the database can be done using JDBC. But if you ask a Java developer about their opinions on coding in JDBC, you're probably not going to get a very good answer. It's generally considered a pain to write code to get JDBC to work. Well, it's not so much the code that you need to interact with the database itself. It is what we call as boilerplate code. We need to write code just to get things working. We need to write a whole lot of code just to open a connection. We need to write code to handle the data, and there are a lot of stuff which we need to do for every application, and we still need to do it because that's required in order for JDBC to work. So in this tutorial, we're going to look at a very simple class which connects to our Apache Derby database that we installed in an earlier tutorial. All we'll do is we will run a query, a select query, and we'll retrieve records. And we'll look at the code that's required in order to just run a simple select and then print out the records. So in essence, this tutorial will be a very quick refresher of JDBC, and if not anything else, it'll help remind us just how painful coding in JDBC is. So let's get started. Here is an instance of Apache Derby running in network server mode. So we have this running, and in the previous tutorial, we created a circle table which had two columns. One was an ID and one was a name. And we also inserted one record for ID 1. We called it first circle. So this should suffice as far as preparing the data is concerned. Now I will write a program that accesses this data. So I'll create a new Java project. I'll call this JDBC demo. And finish. So the first thing that we need to do whenever you write code that accesses databases, make sure that the drivers for the database that you're trying to connect to is available in the project, which means for Apache Derby, we need to include all the drivers so that our project here can connect to the database. So I go to the properties, and in the libraries, I say add external jars, and then navigate to the Derby folder, go to the lib, and here you have Derby and Derby client. Just add them both and press OK. So now we have the reference library having the Derby drivers. So the next step will be to create a model class. Since we've created a circle table, I'll create a circle model class. I'll call the package model, and the name of the class is circle. So this is nothing special. This will just be a simple model class which has two member variables, which is the ID and the name. I already have the code here, so I just paste it. So it has the ID and the name member variables and the getters and setters for the ID and the name. One other thing which I've added here is a constructor that takes in an ID and name, and it sets those two values for the member variables. The reason I'm doing this is actually a common operation. When you're working with JDBC, you would want to initialize an object and add all the member variables and assign them to the initialized object. And since we'll be doing this very often, it's handy to have a constructor that does this in one go. You have a new object, and you also have all the member variables initialized. So in your model class, depending on how many member variables you have, make sure you have a constructor that takes in all those member variables as parameter. So this completes the model class. Now I will create a class with the main method. Say new class. Call this JDBC demo, and it'll have a main method. Okay, so in this main method, I will initialize a DAO, and then I'll call a method of the DAO, which will fetch me the data. So I'll write a DAO now. This will be in the .dao package. I'll call this JDBC IMPL or JDBC DAO IMPL. Click finish. So this class is responsible for talking to the database and getting the value. I plan to implement one method here which takes in an ID and returns the object itself. So I pass in a circle ID and then I get a fully initialized circle object. In order to do that, I will write the method get circle that takes in int circle ID parameter, and then it returns a fully initialized circle. I will have to import circle from the model package, and then I have to write my JDBC code over here. And when I do that, in my main, I can initialize the DAO. I can say circle equals new JDBC DAO IMPL dot. I have to import this, and I have to import circle. So I create a new JDBC DAO IMPL, and then I do a get circle. I pass the value 1, and then it returns me a circle, and then I do a sysout circle dot get name. That's it. So it's fairly simple so far, isn't it? There's actually nothing to it. I'm just calling a method to a DAO, and then the DAO has a method that returns me the object. It's as simple as that. But the complexity lies in the JDBC code that goes over here to actually talk to the database. So we'll have a look at that now. Now, the first thing we need to do is have a connection object. Connection equals null. Let me assign it as null for now. Now the connection is from the Java SQL package. Now after this, what I need to do is I need to initialize the client driver. I need to know the specific string that denotes what the client driver is, and I need to initialize that. I've just copy paste the code over here which does that. So here you see I have a driver string that has the value as the client driver for the Debbie database, and then I need to create a new instance. Now as soon as I write this code, it highlights an error, and the error is that there are unhandled exceptions. I need to surround it with a try catch. So let's do that in just a while now, but let's finish the code over here. So now I have a driver and I initialize it, and now what I do is I create a connection. So the way I do this is this line. So I say connection is driver manager dot get connection, and I pass the connection string over here. So driver manager needs to be imported from Java SQL. And then after this, I create a prepared statement, and then I set the value so that I can use that over here. Prepared statement, PS equals new prepared statement, where you pass the query, select star from circle where the ID is question mark, and then I set the ID over here using a set int. Of course, I'll have to import prepared statement as well. Make sure you're importing it from java.sql. Okay, so now that I have created a prepared statement, I need to actually execute it. So I use a record set and then I execute this prepared statement. I also initialize a circle object so that I can assign the results to this circle object over here. Now the result set is again another thing that I need to import. Okay, so now at the end of this, I have a result set that is the result of executing this prepared statement that I've created over here with the actual query. Now that I have the result set, I need to get the actual object from this result set, which is these lines of code. Now if rs.next, if there is a record, then I'm going to assign that to a circle. I'm doing a new circle. This is the constructor that I told you earlier, and I'm passing both the ID as well as the name. I'm getting the name from rs.getString. I need to know what the data type is, and I need to use the right method so that I can get the proper value, and the name being the name of the column in the table. So once this is done, I close the record set and the prepared statement. Since these two have been opened, I close them both. Okay, and then I return a circle. So the circle is the value that we have initialized over here. I'm going to return that. So just to quickly summarize again, we have a driver that we initialize, we have a connection that we initialize by passing the connection string, then we have a prepared statement that we use. Based on the connection, we use a connection.prepared statement, and the prepared statement will have the query that you want to execute. I substitute the parameters, and then I initialize a result set. Based on the prepared statement, I execute the query of the prepared statement, I get a result set, and then using the result set, I loop through, and then I get the object. If it's a multi-list, if it's a lot of records, I'll have to loop through and initialize a list of objects. But in this case, I'm passing an ID, so I just have one object. I get the object, I close the record set, I close the prepared statement, and then I return the circle. All this just to get an object from the database. So you can understand how painful this is. And believe me, we still haven't covered all the painful points yet. Look at all these errors over here. Every line is having an error marker thrown by Eclipse, and all of them say that these have to be surrounded by a try catch. The reason for that is all these throw SQL exception. There are a couple more exceptions, but SQL exception is a common one that's thrown. What happens if a connection is not got? What happens if there is an error in creating the prepared statement? What happens if there is an error in executing the query? So all these throw a SQL exception. Even rs.next throws an exception. So we need to make sure that all these are inside a try-catch block. So let's put them inside a try-catch block here. I'll open a try, and I'll close this here, and I'll catch. Now what is the exception that I need to catch here? There are a whole lot of them, and you have a lot of production code where there are lots of exceptions that are caught, and there's really nothing you can do about these exceptions. Say there's a problem in connecting to the database. It's not in the scope of the application itself. It's in the connectivity to the database, and there's really nothing you can do except for handling an error condition and then exiting. So most of the times what developers end up doing out of frustration is catching a broad exception, which is not really a good practice in coding, but then you end up doing it because there is only one thing you can do for all the problems that you face over here. So I will throw a new runtime exception. I don't want to deal with it now, I'll deal with this later. So I throw a new runtime exception, irrespective of whatever is the cause, because no matter what the error is, no matter where in this code the error actually happened, it has to do with connectivity with the database, and there's really nothing else we can do. We have to end the execution. Okay, so if you notice, I have not closed one object here called connection. So you see here, connection, I'm just getting the connection, and then I have closed the the record set, and I've closed the prepared statement, but I have not closed the connection. The reason I haven't done that is I have to make sure the connection is closed in all the execution paths. Even if there is an error, I need to make sure that the connection is closed. Not closing the connection has very big impact on the program. If it's a production system and then you have some place where the connection is not closed, it will result in leakage, and it's going to affect the program and the performance adversely. So that's the reason why I will add a finally block here, and I'll close the connection in the finally block. Finally, and connection dot close. Now here's another problem. Connection.close also throws a SQL exception. So even though I put this inside a finally, I cannot just leave it as it is. I need to include a connection.close inside a try catch block. Another big pain point. So I will use a try here, and I will close this, and I'll have a catch. Inside this catch, I can use a SQL exception because there's only one line, and connection.close throws SQL exception. So I'll have a SQL exception, and again, there's nothing we can do about it. And then the close over here, I'll import SQL exception from java.sql, and then finally I close the method closing brace. So you can see how much of a pain this actually is. There is a whole lot of hoops that you have to jump through just to get a record from the database. So however, this is done. We're finally done, and now I will just run this code to make sure I'm getting the circle object over here. I'm just passing a value of 1, which is the primary key of the record that we just inserted in the previous tutorial. I should get the circle here by running this method, and then I'm printing out the circle.getName, which should be, I think, the first circle or something. That's the name that I gave in the previous tutorial. So let's run this. There you go, the first circle is printed. So having seen the trouble that JDBC puts us through in order to get something running, we'll have a look in the next tutorial at how we can use Spring and Spring data support to remove pain points one after the other, and we'll see how we end up with a slightly more elegant code by using Spring JDBC support.